Today we're going to build our own electric race car from scratch. So let's put an electric motor here. Maybe a gearbox here. I'm going to have to put some wheels on. Maybe a battery pack here. And an inverter module here. We're going to need this brakes on these. Those brakes are going to have to connect it to a servo. So let's put the braking servo here. Wire that through here. We're going to need steering and the steering servo. So let's put that steering servo here. We have a cooler for the battery pack. Probably going to run through the battery pack like this. We're going to need a container for the coolant. So as you can see, there's a lot of components to an EV. So let's delve maybe into this. Put 60 kilowatt hours worth of battery cells here. And maybe an 88 kilowatt. What's that in horsepower? 120 something? I don't know. So we've got 126 horsepower. Maybe we can put these motors in series and just double that. Let's put another motor here. We could do the same thing. We could just copy this module and put it in the front, make it a 4-wheel drive. Let's gonna double this again. We might need some more batteries for that. So engineering a car is difficult because we're constrained by space. There's a lot of rules and regulations for driving a car on the road. Specifically, it has to be X amount of width and an X amount of length and even height in order to pass the this is called homologation, to make sure that all cars fit the roads and safety measures put in place. Meaning a battery pack has to fit somewhere in this frame, with the motors, with the inverters, with the containers, coolers, servo modules. And that's just the inside. Then you gotta make the outside. You know, we're gonna put a spoiler on here to get some downforce. So the way this spoiler works is it takes a longer time for air to travel here than here, which is gonna create this air pressure. And it's gonna force the car to go down, just like an airplane, but in reverse. So we get the force pushing the car downwards. This model right here is probably pretty evenly balanced in terms of weight distribution. We have the battery pack in the middle. Also, seats has to be placed here, seat belts. There's a lot of things that goes into a car. And if this is going to be just for speed in a race car, we have to put a cage in here, weld that onto the car. But yeah, it's a one big mess. Right, there's a lot of communication things. We need turn signals, lights, fog lights. All that has to be wired. Maybe have a screen here. Then you're gonna need a processor or graphics card. So you're gonna have a computer in here too. Throttle. It's probably gonna be an angle. Which measures the angle and then gives you the current that you need. All that magic happens with the inverter, because the DC, the battery pack just holds 1 voltage. So that signal is just gonna look like this. Let's say this is, for example, 400 volts. But what the electric motor needs is a signal that kind of goes like this, to get the coils magnetized in different directions. Let's say this is a coil. Running the current this way might produce a magnetic field that goes like this, north here, south here. Running the coil, running the current the opposite direction might give you north here, south here, and that's gonna push off the permanent magnets down here. And these two are gonna repel, and it's gonna swing the rotor. So the inverter is basically a grid, so to speak, of transistors, and depending on how many phases you want. So I've drawn 2 steps into. So this is how the inverter works. This is the first cycle. We turn off these 2 transistors. We let these 2 be active. Notice how the power is going to go. The current's going to go through this transistor, through the load, to find its way back to the other side of the battery this way. But instead, if we activate this one and this one, we deactivate these transistors with the help of a microcontroller. What we now get is a current that goes through here, 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 and through the load this way. So with a battery, we've been able to switch the direction of the current, kind of like this. Let's say this is the current here, I, with respect to time. We're going to have a current peak here, and when it dips into the negative area, that's basically just saying that it's going in a different direction. So this was a simple 4 transistor inverter. I'm going to continue this series on my Patreon. I'm going to call it Build Your Own Race Car from Scratch. I'm going to go over battery technology, how batteries work, how inverters work, even the friction on the wheels as it grips the roads, wings, downforce. I'm going to go over everything you need to know to become an EV performance expert. So check out that Patreon. It's gonna take some time. I'm going to be really busy, but it's a series I hope to grow in the future.